Hello learners, welcome to Try. Today we'll be learning about the executor services. So, going going across this executor service, we are waiting to know we have the different objects that we'll get to know after studying this. We will understand the drawbacks of the manual thread creations. We will use Java's executor service to manage thread efficiently. We'll create thread pool using executors and submit tasks and receive results using Hannibal and features. Now carefully shut down executors also we will learn here. We will learn and see each and everything across while coming through this topic. Now there is a problem with manual thread management. So it states that suppose there is a thread, new thread, it's a new thread, it's a thread, which is a body part, and we have to after starting this thread by putting the dot start method on it. There are too many threads that can overwhelm over system across this thread. There are so many problems that can occur. So we will be watching out one by one. There are too many threads that can overwhelm system resources. The system resources can be taken upon by so many tasks and threads similarly called threads only. Yeah, we can refer them to as threads. No, there's no control over lifecycle on till what time that particular thread will be intervening or working upon a particular method or class. Yeah, so there is no control over the lifecycle. Queuing, which thread will come first or later, that is also not defined. And usability, how many of them use it or not use it. Now they're hard to manage in large applications. Now they're hard, so it's become hard and hectic to manage them in large applications. So creating a new thread for every task is inefficient and risky. So what is a executor class? So what is this executor service? Executor service. It is a part of java.util.concurrent and a thread pool manager that uses a thread. It's a thread pool manager that uses a thread, queues incoming tasks. It will queue up the incoming tasks according to the priority. It will align them and provide better options for task executions. It will give better executions to control over task executions on which tasks to be performed and how the following things could be made up. So coming executor service. So we're making an executor of this executor service. Executor of this executor service equals executor.new fixed thread pool which has the parameters 3. Now here we are creating executor service. Now creating executor service. It has a new fixed thread pool with a parenthesis n. New fixed thread pool. It uses fixed number of threads. It will use the fixed number of threads. It will use fixed number of threads. Now there is new cache. There is new cached thread pool. There is cached thread pool also, which will create new thread as needed and use idle ones. It will create new thread as needed and reuses the idle ones which were set apart or which were set idle. It will use them. Now this new single thread executor. Now coming to this new single thread executor. This one thread task execute is sequentially. It will help the thread to execute sequentially according to their priority or according to the requirement. New scheduled thread pool. Now this coming to the new scheduled thread pool. It executes tasks after delay or periodically. It executes tasks after delay or periodically. Now coming further, we will be seeing various executions. This we are creating executor of this executor service. We are creating executor method of this executor service equals executor.new fixed thread pool. Which is 2, which is implied with 2. We are implying 2 threads here. Now this execute and this executor with a system.out.println task1 message task1 in the system.out.println. Here this task will pass will be passed to the executor. Will be passed to the executor according to a particular thread. Yeah, having a particular thread. Yeah, this task will be passed to the executor. This task one will be passed to the executor. Will be passed to the executor with a thread. Yeah. Now similarly here also is this task two will be passed to the executor. This task two will be passed to the executor with a thread. Yeah. Now coming to the end, we have to executor when we started, so we need to close that. So for that, we'll put an end as executor dot shutdown. We'll put an end as executor dot shutdown. Now submitting tasks with callable features. There are callable features also for submitting tasks also. Now there is enable features. No result. There is no result for this enable and callable and is generic type will be T. Is generic type will be T. Returns a result. It will return a result. Here the callable this will result a result. And feature with generic type T, it holds result for a async consumption. This will hold result for async consumption. For the asynchronized unsynchronized memory space or locations, it will store that results in async consumptions. Now coming, this is callable, which has generic type integer, and task method. Yeah, task method, and there is a sleep. We'll put this thread to the sleep, thread to sleep for 1,000 milliseconds. Yeah, thread dot sleep 1,000 seconds, and it will return a value. Finally, it will return 1 to 3, return 1 to 3. It will return a value 1 to 3. Now executor. Now we have the executor. We have the executor of this executor service of this executor service. This executors has new single thread executor. Executors new single. This executor dot new single thread will execute a single thread. Yeah, executors dot new single thread. This executor equals executor dot new single thread. Yeah. Now feature instead. This is a generic type of this feature function. Feature we are having a we are making a instance of this feature. Feature equals new executor dot submit task. So this will take up the task. This will take up the task, which has the printing line result plus feature dot get. We get up the get, then we will be getting different tasks called by these get functions. We will be getting the different tasks passed here by this get function, and now it wait for the result. This will get the result, and it will wait for the it will get into future. This future will get the result, and will get the function methods. Will get the particular task, and will wait for the result. Finally, this executor is put to shutdown by executor dot shutdown, and we will use get method clearly. So we should use get method clearly. It blocks until the task is ready. It blocks. This will put an pause on the performing class until the particular task is ready. Until the result is ready. Particular result is ready. Now shutting down of executor. Now we are coming to the shutting down of executor. This shutdown method, it stops accepting new tasks. It will stop accepting new tasks. Completes ongoing, which helps in completes ongoing. And while until and unless a particular task is completed, it will shut accepting new tasks. It will stop accepting new tasks. Shut down now. This method attempts to stop all executing tasks. This method attempts to stop all of the performing tasks. And this await terminations. It will blocks until all tasks finishes or times out. All the tasks are until and unless all tasks are finished or timed out. It will block them. Yeah. Now coming further, we have the executor dot shutdown. If in parentheses we'll write executor not executor dot await termination, and until and unless 5 terminations are over, until the time until bit times until bit for seconds. We will apply the time until bit for seconds for this function also, and until and unless this executor not this it will not wait termination and executors until and unless the executor just shut down. Until and unless the executor shut down, this function will be keep on running. Now coming to the parallel task execution. Parallel task execution. This class my task implementation class my task implementation will have the callable of a string generator. We will have the callable of a string generator, which has a field area private int id private int id. It has a field area private int id and my task int id. This is a method. This is a constructor formed with this my id parameter, and this will have the function as this id equals id with the applied id. This id will be given to this id. This id with this id, whatever the id we are providing here, this id will be given to the id what we have passed as the field area. Now coming to this call method. This call method. This will throw exceptions. This will throw the exceptions. This will throw the exceptions, and will put the thread to sleep for 1,000 seconds, 1,000 milliseconds, and it will return a message id task message task plus id that is completed. Message task plus the id that is completed. Now coming to the main method line, we are coming to the main class line. Suppose there is a class executor demo. Suppose there is a class executor demo which has a main method which throws exceptions. It throws exceptions. Now executor service executor. This is the executor of this service executor, and which has the this and this executor has a new thread pool, which has a new thread pool of three new thread the thread pool which are three. There are three thread pools. Finally, we have new threads, fixed thread pools of that is three, and it will here we have the list. We are creating a list of callable of generic type string and list. We are creating a task list of this callable type with generic type string and as an array list. Here it says we have the function as we have to create my task 1, my task 2, and my task 3. Here these three tasks are added in the list as my task 1, my task 2, my task 3. Now the list feature string. Now there is a list of feature string with future of this generative string which results name as this list result list is equals executor dot invoke all tasks. It will invoke all it will start all the tasks. It will start all the tasks. It will start all the tasks. And for future string, we are using a for future string f equals result. We are using for this until unless this f is in the string, the results are found out. Until and unless this function or instances this instance is in the future, the results will be found out, and it will get and this future f will be found out by getting the all those tasks found is have in this list. Yeah, in this list all the tasks will be get using f dot get. Now finally we have started the executor class, so we finally coming to we have to shut down as we have started them. So it will check for the all the tasks are performed or not. Executor or shutdown. Yeah. Now finally we coming to the end. We have different suggestions as we have learned for here. We have used executor service. We have to use executor service instead of raw threads. In most applications, we have to use executor service. Now we have to prefer callable features when you need result. When we need result, we have to call this callable or plus the feature function. Yeah. Now always shut down executor of free resources. You have to always shut down the executor to free up the resources that are not utilized or not used. Now we should use invoke or invoke any to batch submission. We should always start or invoke all for the or invoke any for batch submission. For every batch submission, we should start a particular function or method. For that, we should use or invoke all or invoke any. Now, thanks. We'll meet up in the next class. Thanks.